So, in last session, student, we have discussed about the various sensors in satellite. Last time we have discussed about what? Kalpana 1, which was made for meteorological purpose and for the climate and earth observation, right? In the name of Dr. Kalpana Chawla. Now we are going to discuss about SARAL. What is SARAL? Satellite is a joint Indo-France satellite mission for oceanography. SARAL performs algorithmic measurement designed to study ocean circulation and sea surface elevation. Means here, especially we are going to study about sea surface elevation and ocean circulation. Means the related terminology for oceanography and sea surface elevations can be known. Again, this satellite is polar sun synchronized. Here, student, I have shown very less number of satellites and sensor. But in today's time, we have launched many sensors, satellites. As per the requirement, we have taken the information. Through this, I would like to say that according to the requirement of frequency wavelength, we are making the sensors. So these are Researchsat, Kalpana 1, Saral, all have different purposes and all will gather different energies from different features. So now next we will discuss data is identified and what basis the feature are extracted. Here, I would like to draw your attention, students. See, now data is captured, but how is the features are extracted? Now, if I see a image, see the simple image I can make you show the image which is not with the white spot, the plain image. You can see only two color. There is one green color and the light reddish color type thing, right? That is our image. But how can you identify that what does that green color show, or does that brown reddish color show, right? So for that extraction, that is very much important, that we do not misguide ourselves while reading the image. Why? Because the basic property which allows identification of the object is called signature. Every feature has its own signature, and through that signature and other relevant information, we can get that what does that image means. Now, any set of observable characteristics which directly or indirectly leads to the identification object or its condition is also called as signature. It does not mean that signature means one particular signature. There is sometimes a characteristic which is directly or indirectly related to it. The purpose of showing this is majorly what, that when the image is obtained, then what is the further process can be done. So first further process is to identify the objects and to give the signature to it. That is known as identification. And yes, now look to the next image, that is the white substance present in the image. What is that white substance present in the image? Can anybody tell me? Yes. If you think, I think you have think that white substances are cloud, which is the noise present in the our image. So this is how, if these clouds are present, then we cannot use that data for the analysis, because due to that cloud, our much more area is cannot be extracted, and hence what happens, we cannot properly calculate the area, we cannot properly make the decision, we cannot properly model it. So cloud is one type of scattering which have occurred, and that is why they have shown us the cloud image in our image. So data identification is important and features are extracted by its own signature. So every image has its own signature, and according to that it will take the information. Now next, various types of satellite image resolution. Why it is important? Yes, this is very much important to understand about the satellite image resolution. First is spatial, spectral, temporal, and radiometric. Here in this module, I will not much brief you about it, but yes, you should be knowing it, because we have studied about the sensors, about the satellite, about the specification. So you should be knowing that how are the specifications are adjusted into the sensor. So in this remote sensing terminology, student, we have four main types of resolution, that is spatial, spectral, temporal, and radiometric. This topic is very important. From this topic, from these characteristics only, we can further on derive the image, we can further on see the image, we can further on decide the image, what more can be done. So here, if you see, first is spatial, spectral, temporal, and radiometric. What is spatial word? We have already discussed. What area and how detailing it is done. That is known as spatial. Describe how much detail in a photographic image is visible to human eye. Spatial is how much detailing is described in photographic image and it is visible to human eye. Means how much area is covered and what detail is done of that area is spatial resolution. Next is spectral. What is spectral? What color and band? Number of spectral bands. Right? So here in this, spectral means various number of spectrum. Spectrum, you understand the spectrum? There are various colors. So similarly here, spectral means various bands. Green, blue, NRI, VRI, etc. Near infrared, far infrared, very far infrared. Right? That is known as VI, NRI, SWRI. The all are related to spectral. Means data is captured in such a way in different bands and different band gives us a different information. Next come resolution is temporal resolution. What is temporal resolution? Temporal resolution here it means time of day, season, year. Difference can be detected. Phenomenal changes can be detected. Revisit is done in this day. Temporal means with different temporary seasons we can take the image. If we are taking the image of crop in January, then the same image will be taken in the December month. So we can ultimate do the comparison and we can get the change of it. Next is radiometric, that is the color depth. It depends on which band data is recorded and number of bit in which data is recorded. More the number of bit, more the data and more is the good analysis. So spatial, spectral, temporal, and radiometric means this, which is very important. Now we will see according to the figure. You see here, first figure, I have shown what fine and high resolution, coarse and low resolution. If there is a fine and high resolution, means the spatial resolution is high, then you can see that is 10 meter. 10 meter has a good quality of image, good identification of image, but area is not much seen. If we go to 30-meter resolution, area is much, and 80-meter resolution does not give good image. That is coarse and low resolution image. This image is of what? This image is of spatial resolution. Now going further to the spectral resolution. What is spectral resolution? You can see here multi-band and different bands are there. These different bands make a combination and they form one clubbed mosaic image. What is mosaic? Stacking. Everything is stacked and they have made the puzzle like one image. That is known as spectral band. Right? Next comes what? Temporal and radiometric. Temporal, you can see here I have shown January 2015, January 2011, 20, 1995, 2000. Right? That is a temporal change. You can see the color coding temporal change can be clearly seen by eyes. And other to that, there is a radiometric resolution. What is radiometric resolution? You can see the image which is shown is if it has a good bit, then you can clearly identify the substances, objects, places, right? But in the left side image of black and white, you see there is no proper correlation between the image, right? Now moving further, the new concept is to be studied, which is known as false color composite of image. What is false color composite? Yes, this is very important. The image of earth I have shown here. The earth, you see, somewhere where there is a black, where there is a green substance, it is shown in green in the next image, right? So you can see black is shown here in the red. The main aim of false color composite of image is what? False composite allow us to visual the wavelength the human eye does not see near infrared range. So here, if human eye cannot identify, if human eye cannot see, then these all bands will transfer its energy and can be seen. So how can it be transferred? We all know that primary color is red, blue and green. So in this red, blue and green, they mixes the band and give us the information. Remember, false color composite gives us eyes to identify the object in very proper way without misguiding our cells. Right? Red, green, blue are the primary colors. Now, here you can see to the image that I have shown. First is the natural image taken by the sensor, and then the spectral resolution is been applied, and this spectral resolution shows us that what are the characteristics of it. Similarly, last image also shows us that how is false color composite applied to it. So this is the component, that is false color composite of image, which is very much useful. This false color composite terminology we will much more read in detail in another module, but in this reference you have to remember what is false color composite. So till now student, here we have done false color composite, the various resolutions of satellite images, which is very important and practical question. And resolution says what? Identification of the feature is done by what? Signature. Which are the sensors, and sensor says us what and for what sensors are made. These topics are much further information, but it should be properly known. Thank you students. In next lecture we will study further.